Okay, welcome to part 4. This chapter is a little longer than the others, so there's 4 parts, another 10 minutes of discussion about local and regional winds, and this should help you understand more fully how the global wind circulation patterns work, as well as understanding what's going on at the local level. So let's talk about land and sea breezes first, because many of you have probably been to the ocean and experienced a bit of this. Maybe you have also experienced the mountain valley breezes. We'll talk a bit about monsoonal winds, but we'll start here with land and sea breezes. Essentially, the way this works is that during the day, land heats up, or air heats more quickly over land, and it rises. Air over the ocean, especially if the ocean is cool, descends. It sets up a pattern in which there is a vacuum created over the land that sucks in the air that is descending and being pushed out by the higher pressure over the sea. At nighttime, the pattern is reversed because water has higher specific density, which we had already talked about. It stays a more constant temperature. The land heats up and cools off quickly, so at night it cools off quickly, long wave radiation is escaping, but the temperature is decreasing. Decreasing temperature means the air is heavier and it cools, it descends, it must go somewhere, and it returns some of it to the sea where it is relatively warmer and then rises. If you're standing on the beach, you should feel a land breeze during the night and a sea breeze during the day. Keep this in mind because this pattern is very important if you live in California when you want to understand Santa Ana wind. If you are hiking in the mountains nearby, or perhaps you get lucky and get to go to the Alps or something, you will notice during the day, as you're walking, say, along a trail here, during the day, that warm air, because it is hot, is rising up along the mountain. And if you were walking along a path, you should be able to feel that air coming up the valleys. At night, or still early in the morning, you can be walking along and feel cold air descending down the hillside. Large-scale versions of these mountain breezes are called katabatic winds. And if you combine both the sort of katabatic winds and this land-sea wind pattern, you can get what we have in Southern California that is known as the Santa Ana winds. They're sort of a local monsoonal wind that is very strong, and in the autumn, September, October, November time, we can get very strong winds in Southern California, and they can bring with them a greatly increased chance of wildfires. The most famous of monsoonal winds are the ones that occur over Asia. In winter, and monsoon, by the way, means wind, not rain. In winter, cold, dry air comes out of Siberia and spreads across all of Asia, but particularly heads towards the Indian Ocean and the warm Pacific Ocean. It flows from north to south and dries the land out. In the summer, a great low pressure forms over Siberia, a great supermassive version of a sea breeze that brings wet, humid air from the warm Pacific and the warm Indian Ocean over in towards Siberia. And when it crosses the high mountain ranges, or even some of the lower ranges of Asia, prodigious amounts of rain come out of the sky. This is a special kind of rain called orographic precipitation, and we will investigate that later. Here's a graphic of how that works. High pressure occurs over Siberia during the winter months. It pushes dry, cold air out of Siberia across much of South and East Asia. During the summer monsoons, the intertropical convergence zone moves high over the Indian subcontinent, over East Asia, bringing with it winds that are dragging warm and wet air in towards Siberia, in towards this intertropical convergence zone, where there is this massive low pressure system and crazy amounts of rain fall. You see that during the winter months that some of these areas in India get less than an inch of rain a month, but then during the monsoonal periods they can get over 15 inches of rain per month, and then during the winter it returns. This creates a cycle of life that people in Asia have relied upon for thousands of years, but it also presents great challenges for engineering, for agriculture, for living in general. The last part of this chapter deals with how the winds blow along the surface, the water on the surface of the ocean. So the same patterns of wind are recreated largely with the ocean currents. The Coriolis effect that changes the direction of wind also forces the circulation of oceans to another degree. Where the winds are not available in the deeper parts of the ocean, these patterns are not replicated. The most important part for this course is to once again take a look at the North Pacific Current, or what's called the Alaska Current, and how that makes the water cold off the coast of California, and our opposite number, the Gulf Stream, once again characterizing the warm water off the coast of Florida and the Carolinas and bringing warm water towards the western coast of Europe. Same pattern is replicated over the entire Pacific and Atlantic Oceans. The only difference in the South Atlantic and the South Pacific is the direction is counterclockwise down there, where it is clockwise in the northern hemisphere. The last slide is about the deep ocean currents, which are called thermohaline. Thermo is a reference to the temperature of the ocean water, and haline is a reference to the salt content in the water. Salty water, largely that has been had a lot of the water evaporated out, leaving only the salts, is heavier. Cold water is heavier. So when the water moves northwards or poleward and gets colder and saltier, it sinks to the bottom of the ocean. Water off the coast of the United States in the Gulf Stream moves to the Greenland Sea, where it gets colder and it sinks, goes towards the bottom of the ocean, and begins this very, very long circulatory pattern where it may take 1,000 years before it reappears at the surface, and that is called upwelling. These areas of upwelling are extremely important for fishing and the health of the marine system. One of the great fears associated with climate change is that when the Greenland ice sheet melts, there will be so much fresh water, which is not salty, pouring into the North Atlantic that it will not allow ocean water coming up out of the Gulf to sink, which would touch off climate chaos. For some reason, I don't have a slide on El Nino, so I will momentarily explain it. El Ninos occur every 5 years or so, and essentially what happens is that the standard pattern of oceanic circulation of water going westward across the Pacific Ocean is reversed or changed, and the water returns in an easterly fashion, which allows it to heat up a great deal off the coast of the Americas. This extra huge sized pool of warm water changes the standard climatic system that works in the eastern Pacific and brings really quite different weather to not only the Americas, but even to other parts of the world. I will put a video online that explains that in greater depth. So back to this last summary slide. Make sure that you know these, plus a bit about El Nino and La Nina, and that ends chapter 6.